Alright, so we are back to square one, which we have previously postulated that this is the structure, but going through all the reactions towards the last point, um, it did not fulfill the tertiary alcohol component for compound F, and even if it were to fulfill all the other criteria, as long as it did not fulfill one of them, it will not be the appropriate structure. So let's try the alternative, which is out of the three that we have looked at, which is able to form 4 different monobromo compounds. We still have this structure over here that we can work with. Okay, so the question is this compound A? So let's go through the different steps again. So looking at the reaction, if I am going to substitute the one in pink for the hydrogen with bromine, this is the product that I will get. Okay, so this is the portion that we are looking at. Let's move on. If the one that is highlighted in blue is the one to be substituted, let's look at what it is. Okay, so this is the one that is in blue that is being substituted. Let's move on. If it's the one in green, okay, and finally the one in orange. Okay, so these are 4 different products, which is what we are looking out for A that undergoes free radical substitution on the side chain. Okay, and moving on, among all these 4, there could be the presence of compound B and C, which undergoes elimination to form the same compound, and the compound can exhibit cis-trans isomerism. So let's look at the elimination product and see whether we can find any species which are the same. So let's look at this. Okay, when it eliminates with adjacent carbon, it can be removed from the hydrogen over here. This is adjacent. Okay, so these are the species that's removed from. Alternatively, it can also remove hydrogen from this as well, because essentially these 2 carbons are adjacent. I can remove one Br and one H from this. So alternatively, this could be the one. Okay, you'll be left with a CH3, a H, and a CH3. Okay, let's look at the next one. Over here, the 2 adjacent could be this Br and this H, and let's see what it would form. Okay, and the remaining is this. Okay, let's see if there is a OR. Okay, over here there's no adjacent carbon in this case, because the carbon next to it, there's only one carbon next to it, which is this carbon, and there's no more hydrogen that is available anymore. Okay, let's move on to look at the next one. Okay, in this case, I can choose to remove the Br and H like this. Okay, and let's look at the products that it would have. Okay, alternatively, the Br can be removed again from adjacent carbon, which is having a hydrogen over here. And in that case, let's look at what would be formed. Okay. And finally, for the last one, it can only remove from this hydrogen on the left-hand side. Okay, so these are the products that we have, and let's look at the question again. So if you look at what the question has mentioned, it says that out of these four, on the left hand side, which is the alkyl halide version, there consists of B and C, which can form the same compound that exhibits as cis trans. So let's look out for same compounds first. So if you look at this and this are the same, but I will eliminate them because it cannot show me the identity of B and C simply because it doesn't form D and E, which are cis-trans isomers, because the CC double bond has 2 hydrogen on one of the carbon over here. So this would not be what I'm looking out for. I will continue to search for them. Okay, so I put a cross over here. This is not what I'm looking out for. Let's look out for identical structures moving forward. So this is identical structures. And there's one more identical structure over here. Okay, but again, I would eliminate the one in blue simply because the CC double bond has 2 identical groups on one of the carbon. Okay, and now the one in red is the one that is possible, meaning that in this case, this structure is either B or C, otherwise this is B or C. Okay, so that's what we are looking out for. Let's continue. Among this, if one of them is capable of forming a tertiary alcohol, this would be what we are solving. So I'm going to copy this possible structure and ask myself if it can form a tertiary alcohol. Okay, so let me just erase the highlighted portion. Okay, so if this is B on its own, okay, when it undergoes a reaction with aqueous NaOH, let's see if it can form a tertiary alcohol. Okay, and in this case it does, because this group over here consists, the C that bears the OH has 3 direct carbon neighbors. This is a tertiary alcohol, meaning that this structure is the correct structure of B. Okay, let's try the other one. So meaning that this is correct, let's just do a double check. And I'm going to copy this over. I said that this could also be B or C as well. So let's just confirm. If it's not, then this would be structure C. Okay. So in this case, this is a structure that forms the same compound that exhibits cis-trans isomers. So if I were to look at this, when I sub it inside, okay, this is going to form a secondary alcohol. That's because this carbon has 2 immediate carbon neighbors. This is a secondary alcohol. So I said that one of it is a B, one of it is a C, meaning that I've already solved for this. This is structure C. And that would mean that compound F is solved. This is actually compound F, because B reacts with aqueous NaOH to form a tertiary alcohol, which is compound F. So we have solved for B, we have solved for C, we have solved for F. Okay, going back to this, that is to say that, is this A? The answer is a yes. So this is the correct structure of A. I can remove the other two at the side, on each side already. Moving back, we have solved for A, B, C, and F, leaving D and E, which are cis-trans isomers, which we know that this is the same compound that it can form and it can exhibit cis-trans. So I'm just going to reconfigure it so that I can get the answer. So all in all, okay, D and E would be as such, showing that it's a cis-trans. Okay, we need to show the trigonal planar shape with regard to the, with respect to the CC double bond. So in this case, okay, this configuration that I'm showing is actually a cis because the heavy groups on each side are pointing on the same direction. So the carbon on the left, the heavier group is the benzene ring or the phenol group, and the carbon on the right has the heavier group, which is CH3. So this is the cis version, and that would also mean that the trans version would be just switching one of the sides. Okay, I'm going to keep the left carbon having the same group. The right hand side I will switch. Now in this case, the heavier group is pointing in opposite direction, and therefore this is the trans version. Okay, and that is compound D and E. So which one is D, which one is E doesn't really matter because they did not mention specifically whether D is a cis or a trans. So if you were to swap D and E around, where D it's the trans, E is the cis, it's also fine. So that is the answer that you have for this elucidation question.